All right, so we're going to talk about convex mirrors now. And here's the general picture of a convex mirror. So we have our curved mirror, and in the case of a convex mirror, the reflective part of the mirror is on the outside of the curve. So on this side, I've set up our mirror here. We have our optical axis here. We have our focal point, which is on the inside of the curve, always on the inside of the curvature. And we have our object and arrow. And again, I'm going to show you a couple rays that you can draw to help you figure out where an image is located for a convex mirror. Okay, so in a similar way as the concave mirror, we are going to also assume that we are sitting in the parabolic region of the mirror. So any light rays that come in parallel to the optical axis will be reflected through the focal point. And it looks slightly different for a convex mirror, but we're going to see that now. So we're going to draw our first light ray from the tip of the arrow parallel, as best I can, to the optical axis. And given what I just said about being reflected through the focal point, now we know that this is a reflective surface. It will be reflected to the opposite side, but we can draw, we can sort of extend the reflected ray backwards through the focal point, and that is the angle at which that light ray will be reflected back. It will go through this focal point here. So this is sort of our virtual light ray of that extension of that reflection. And now I'm going to draw, that's one light ray that we can draw. We're going to draw a second light ray, again using the law of reflection at this center point. So we can draw a light ray that hits the center point there, and it will be reflected at the same angle that it was incident on. So we can just draw that right back that way. That's the reflective part. And then we're going to extend the reflected light ray backwards. Okay? So right away we can see we have this intersection point, right? And we can say that our image is right there. So I can draw a little arrow right at that point. That's our intersection point. There's our image. There's one more light ray that we can draw, and I'm just going to show you. It's not going to help us with our image, but it can be useful to see this other ray just in case. And the way that this light ray works is it's going to go the opposite way of this first light ray here. So if we have some kind of light ray that is, let's see, coming in like this, it's going to be extended backwards like that. So this light ray that's coming in at this angle here, that's pointing towards the focal point on the opposite side, will be reflected back parallel to the optical axis. All right, so that's sort of a third light ray that you can keep in your pocket, just in case you get into a situation where you need this type of a setup. This is sort of the diagram of that. Now going back to our object and our image here, here's our object, here's our image. In general, for convex mirrors, we will have negative focal lengths. And what we can say about this image is this is a virtual image, right? There are no actual light rays traveling to the location of that image. And so what we can also say is that we will end up with a negative image distance as well. Okay, so that is how you draw a few rays to figure out where an image is located for a convex mirror.